Project 110, Energy Transmission Loss, explains how electric power is lost over time as it is traveling from one place to another through wires. That is because of resistance. This circuit has two paths for electricity from the battery to flow to the meter, the LED, and the fan. The meter is set on the 5-volt setting, and the slide switch is used to control which route the power flows through. When the slide switch is set to position B, the electricity flows through the shorter route, and just over 3 volts of power is generated. However, if I was to move the slide switch to position C, the electricity will take the longer route, and you can see that it is less than 2.5 volts. The long route contains the pivot stand, which has a resistor simulating a long distance power line. And even though they have low resistance, the longer the electricity is flowing, then the more power will be lost. And that's why in real life, electricity is transported long distances with high voltage and low current, because less power is lost. Then transformers reduce the voltage to 120 volts so that it can be safely used in homes and offices. You can remove the LED or the motor and see if that affects the performance. Less current will be lost, or less voltage. I'm using the big route this time. You can see that without either of the components, it is over at least 3.5 volts for the long route, and similar, but the components really make a difference in the amount of voltage that is lost. This circuit talks about regulating power, Project 111. We have the LED, and we will set the slide switch to the B position to begin, and the meter to the 50 milliamp setting. On this setting, the meter reads about 27 or 28 milliamps. But when I move the slide switch to the C position, the LED will dim and the current drops to 15 milliamps. Now we replace the red LED with the yellow one, and let's see how much current is used now. On the higher setting, 10 milliamps is used, and then on the lower setting, about 6 or 7 milliamps is used. Now we have the motor, and on the higher setting, at least 30 milliamps is recorded, and then on the lower setting, only just over 10 milliamps is recorded. And this project simulates how electrical devices in your home may have different settings, such as lights and fans, and to reduce the amount of power that is being consumed and save energy, run lights and motors only at the setting that you need them. Example, don't have lights brighter than they need to be, or motor fans spinning faster than they need to. Therefore, you can save money on electricity as well as reduce pollution. This project allows you to select either wind power or solar power for the red LED by using the slide switch. When the slide switch is set to the C position, sunlight will power the red LED. When it is set to the B position, wind will power it. And you spin the motor. It might be hard to see, but the LED will light up when it spins fast enough. Yep. And it would be more wise to use solar power when in bright sunlight, but use wind power at night when sunlight is not available or on a cloudy day. Project 113, hybrid, requires you to set the slide switch to the B position, the meter on the 5-volt setting, and to turn the hand crank in a clockwise direction. When you do, the fan and LED will come on and the meter will record the voltage. And this circuit is called a hybrid because it can either run on energy produced by turning the hand crank or that is stored in the C5 capacitor, even though the latter does not store a large amount of energy, so it would not be able to power it very long. Hybrid means that something can run on two sources of energy, like a hybrid car. Project 114 explains the concept of a hybrid car. A hybrid car has both a gasoline engine and an electric motor. Now, in this circuit, when the slide switch is set to the C position and I turn the hand crank, the red LED will come on to indicate that the battery is charging. And then, when I move the slide switch to the B position, the battery powers the fan and motor. And then if I use the turn the hand crank, it will also charge the battery and run the motor. So, if there was no power in the battery, I could still run the motor with the hand crank. Hybrid cars are very efficient vehicles because they often run on electricity at low speeds, yet switch to a gasoline engine at higher speeds. When the vehicle is idling or being parked, the electric engine would be used because it's more efficient and more environmentally friendly. What's also very interesting about hybrid cars is that usually energy that may normally be lost through coasting is actually used to power the battery that runs the electric motor, to charge the battery, so that power is never lost. You never have to plug the car into an external power source to charge the battery, unlike some other electric vehicles. Project 115 shows the difference in electrical efficiency between LEDs and incandescent bulbs. You might wonder why I'm using the radio, but that's because it has a built-in incandescent lamp, and the voltage meter, which is set on the 50 milliamp setting, will measure the current from the LED, the yellow LED, as well as the incandescent lamp on the radio. Now the radio is off, and about 10 milliamps is generated by the yellow LED. But I am going to turn on the incandescent lamp on the radio, and the voltage is the current is way too high for the meter to record, even on its highest setting. That shows that incandescent lamps use a lot more energy than LEDs. That's why a lot of lighting applications use LEDs instead of incandescent lamps, because they are more efficient. And not only that, LEDs last longer, they are more compact, they do not give us off as much heat, since incandescent lamps often waste most of their energy as heat. And so they're used in homes, offices, outdoor lighting, and so many other lighting purposes. Project 116 is water timer. You will need a cup of water for this project, and we will put the exposed ends of the jumper wires into the cup of water without them touching each other. And depending on the quality of the water, the red LED and the clock will come on. Now it's inverted. I can turn this around and it says 12:01, and the red LED indicates that the clock is working. Now, I will not be able to really demonstrate the second part, which is actually the primarily portion of this project. But if I was to remove the water from the jumper wires, the clock will go off and then hit the S2 switch, the press switch, to reset it. And then you would put the empty cup under a faucet. You would leave the wires in the empty cup and then put it under a faucet or gutter drain, and when water goes into the cup, the clock will start. See, it's now 12 o'clock again, not 12:01 like it was before. And then if you go away and return, you can use this clock as a timer to find out how long ago water first entered the cup. And if you keep the actual circuit dry, you could actually use, if it was like heavy enough, you might actually be able to, I don't know if it would be successful, but you might actually be able to keep the cup in rain, and you can know how long ago the rain began. Project 117 is solar fan. The meter will be set on the 5-volt setting, and I am going to hold the circuit up to my desk lamp, and depending on the angle of the solar cell relative to the light source, the meter may reach nearly 4.5 volts. Now I'm going to try, I don't know if I can do this one-handed, but like I'm going to push the press switch and the motor should spin. And if it doesn't, but if it was to, the voltage would drop because the solar cell cannot produce sufficient current for the fan to run, and therefore the voltage would drop as the fan spun. This is the same thing with water. A pump might push water through a narrow pipe at high pressure, but if the pipe is wider, the pressure will drop because the pump can't push as much water. Project 118 is hand radio. This is very simple, but you simply turn the hand crank to run the radio, and the capacitor will store the energy for it. Now, I have told you how you operate the radio in previous projects, but what is good about this radio is that you can take it anywhere, and although the reception may not be good everywhere, you could use it without the need for batteries. So if you're like, let's say, in the wilderness, or stuck in your car during a storm, or stuck in your house and the power has gone out, and you don't have any battery-operated radios, you could use this one. And hopefully you'll be able to get at least a few stations with clear reception. Project 119 is hand charger. The meter will be set to the 50 milliamp setting for this project, and the slide switch will be used to control whether or not power generated by turning the hand crank goes to the meter or the battery and yellow LED. Right now, it will go to the meter. And when you turn the crank clockwise, you can measure how much power you are generating by spinning it. And then, if you move the switch to the other position, the current will be flowing to the yellow LED and the battery. This is yet another way you can charge it.